So now we're going to look at something called replacement versus non-replacement probability. And in certain situations you have a scenario where a part of the problem is to create a tree diagram where you have something that you take and put back, and another situation where you don't return it. So we're going to look at this first one, which is replacement probability. And so if we have this bag and we say that the bag contains 5 red and 2 green marbles, so there's a total of 7 marbles in there, 5/7 of them are red and 2/7 are green. Then if we think about choosing a marble and then replacing the marble and then choosing a second marble, what are all the probabilities of the different outcomes? So again, I'm going to use a tree diagram to illustrate this point. So if we were to reach in the bag, we could choose a red or a green marble on the first draw. And the probability of choosing a red one is 5/7, and the probability of choosing a green one is 2/7. And then we put the marble back in the bag and we again reach in and choose a marble, and again we could pull out a red one or a green one, or a red one or a green one, depending upon which we pulled out the first time. And again the probabilities are 5/7 and 2/7 for each of the colors. And our different outcomes are red red, red green, green red, or green green. And the probability of choosing the red red is the 5/7 times the 5/7, or 25/49. And the red green is 5/7 times 2/7, or 10/49. And green red is 2/7 times 5/7, which is 10/49. And then green green is 2/7 times 2/7, or 4/49. So those are your different outcomes, and that's if you put the marble back in each time before you draw another marble out. Now everything changes, so those are my scenarios, those are my different probabilities that I would record, so we want to keep track of all those. But what if we did the same thing but we don't put the marble back? So we take a marble out and we don't put it back before we choose a second marble, and that really changes everything. We remember that there are 5 out of 7 reds and 2 out of 7 greens, but that's if all the marbles are in the bag. So we're going to make a new tree diagram and think of this scenario. The first draw, nothing has changed, so we have red or green, and it's 5/7 or 2/7. But now on the second draw we actually have one less marble in the bag, because if we pull out a red one, there's going to be one less red marble in the bag. So if we look at this scenario here, there were 5/7 red, now there's one less red, there's only 6 marbles in the bag and 4 of them are red. So we no longer have the same scenario. We have, instead of 5 out of 7 red, 4 out of 6 are red, and then there's still only 6 in there and 2 of them are green. So we have 4/6 red, 2/6 green on that second draw, because there's now one less marble, only 6 in the bag. And so that's our new scenario on that branch. And then on this branch, if we'd taken a green one out first, now there's one less green marble in the bag. And so again, there's only 6 in the bag on this draw. Now if we drew a green one, then all of the red ones are still there. So there's 5 out of 6 that are red, and there's one less green, 1 out of 6. that's green because we took away one of these green ones in this branch. So now everything is kind of, you have to really look at each branch and see what you have happening in each situation. So for red, we have 5/7 times 4/6. So we have 20 42s, 40-seconds. 7 times 6 is 42, 5 times 4 is 20. To get red-green, 5/7 times 2/6, or 10 42s. And we could reduce all these fractions, by the way, so let's do that when we can. 10 over 21 and 5 over 21. And then green-red, 2/7 times 5/6, or 10 out of 42, or 5 out of 21. And then green, 2/7 times 1/6, or 2 out of 42, or 1 out of 21. And so now we have this probability non-replacement. And again, everything changes because you actually have one less marble in the bag on the second draw than you do on the first, because we don't put this marble back in. If we pull a red one out, we leave it out. If we pull a green one out, we leave it out. And so you can see how all the probabilities now have changed from what we had before when we put it back in. These were out of 49ths. We had 7 in the bag for both draws. And now, with non-replacement, we have 7 in the bag on the first draw and 6 in the bag on the second draw. So that is an example of replacement versus non-replacement probability. Two different situations that result from that. It changes all the probabilities. So you have to be careful and know whether you're doing replacement or non-replacement probability. So if we do this again, we think of a different scenario or different numbers. So now it says in this second scenario that now we have 6 red and only 1 green marble. So we get some interesting things happening in this case. If we think of 6 red and 1 green and 2 draws. If we did it replacement, so we'll do it both ways. Here's with replacement. So we have a red and a green, and so if we have 7 marbles in the bag and 6 of them are red, 6 out of 7 red and 1 out of 7 green. So we have 6/7 and 1/7 on the first draw. And if we replace it, we put it back in, then we still have 6/7 and 1/7 for red and green. 6/7, 1/7. And so our probabilities with replacement, 6/7 times 6/7, which is 36/49 for red, for red-green, 6/7 times 1/7, or 6/49. Green-red, 1/7 times 6/7, or again 6/49. And then green-green, 1/7 times 1/7, or 1/49. And really you can see from the fractions we have the same numbers of marbles in the bags for both draws. So we've replaced the marble after we took it out, and then we drew again. And so these are the probabilities with replacement. Now I'm going to leave this one up so you can see directly what happens when we don't replace the marble. So if we have red, then green, 6/7, 1/7, and then red, then green, or red and green. Now, there's only going to be 6 marbles in the container now on the second draw. And if we took out a red one, there's only going to be 5 reds left because there were 6, now there's 5. And all the greens are still there, so 1 out of 6 are going to be green. Let's see how that changes in our second draw. And then in this case, if we took the green one out, and there's only 6 in the container, then they're actually, all of them at this point are red, and there are no green ones. So if we pulled a green one on the first draw, since there's only 1 in there, we know we're going to get a red one for sure on the second draw. So let's look at the probabilities of each of these as we go. So red is 6/7 times 5/6, or 30 out of 42. Red-green, 6/7 times 1/6. I'm just following these chains in the tree. And then I have 6 out of 42. And then to get green-red, so I have 1/7 times 6/6, which is this like 1. So 6 out of 42. And then very interesting on the last one, to get green, of course, is impossible when you only have 1 green in the container. And so we have 0 out of 42 chance of that happening. So again, you can see that this is with replacement. You put the marble back in, and this is with non-replacement. You can see that first draw there's 7 in the bag, there's second draw there's only 6 in the bag, and you have to take that into account as you do the probabilities in the second set. In the first one, the probabilities don't change from the first to the second because we put the marble back in. In this case, the marble is not there, and so the reduction in the denominator, and in some cases the numerator, depending upon which marble you pull out and choose. And so that's how you calculate replacement versus non-replacement probabilities with multiple situations. And there's a lot of scenarios where something is drawn and then either put back or not, and you have to know which you're doing, whether you're putting it back in and being able to grab it again, or if it's removed from the possibilities that you use. So that's probability 28.